Good morning. We're in Cruickshank Botanic Garden in the month of March. We're on the crocus lawn, the labyrinth lawn as we tend to call it, because indeed behind me you can see over 4,000 crocus vernus showing their beautiful late winter, early spring flower colour, purples, the mauves, the yellows, the white petals. It is a harbinger of spring, and I use that phrase in a term of generosity perhaps, because even today it is 1 degree Celsius air temperature. Fortunately, very little breeze, so there's no wind chill to consider, but we have had a 4-week period since the last filming of a weather breadth that has been significant and memorable, but arguably for all the wrong reasons. We've had days of driving rain and very cold temperatures where the only thing you'd wish to do is stay indoors. We have had days of snow. Indeed, I had the pleasure of being able to talk briefly in such conditions outdoors in the garden with Dr. Leslie Lancaster, looking at rhododendrons and how they change their leaf morphology. We're in Cruickshank Botanic Garden, and you may be able to see directly over my shoulder a plant you'll have recognised from the previous episode. We have wonderful Hamamelis mollis, the witch hazel, the yellow blooms, slowly going over now after 6, 7, 8 weeks of being in flower. But it's a winter's day. We've got snow on the ground, we've got gentle flurries falling around us. You might even be able to hear bagpipes in the background. We're close to St Michael Cathedral. Clearly somebody is being brave enough and happy enough to have a wedding today in these conditions. Makes you wonder what it feels like to be wearing a kilt, doesn't it? What we also have here is a rhododendron, and it's looking particularly unhappy. Looking slightly more amused and a little more happy is a colleague of mine, Dr. Leslie Lancaster. Leslie, you're an ecophysiologist.
That's right.
And I've dragged you out into these conditions, particularly to look at our rhododendron collection. This is visually identical to almost all of our rhodos at the moment. We've had a fascinating conversation where you're interested in a student dissertation project where different leaf material of different plants can be tested for heat and cold tolerance. And I told you that some plants, even on a day like this, don't have the woolly hat, don't have the coats, but do try and adapt in cold conditions to stay warm. And I wanted to bring you out and show you this. So you've had to dress warm, I've had to dress warm, but here's a very good example of leaves curling up, trying to get smaller, less surface area against cold biting winds and cool temperatures.
Yeah, it looks like a really interesting adaptation that they have to be able to do that in such cold weather. It's really fascinating. I mean, on the surface it looks like they're unhappy, but really they're actually doing something pretty complicated in order to adapt to the cold.
Absolutely. A survival technique. The leaves also droop, they become more pendulous, and again that's trying to reduce surface area against biting, blowing winds. So if we were, Lord knows how long we're going to have to wait for this, if we were to stand here on a warm day, good sunshine, then we would see a very different visual appearance.
Yeah, extremely different. It almost looks like behavior adaptation in the plants, and I think that's really interesting.
I think that's a super phrase for it. So I wanted to show you this. We could walk the rest of the garden and look at other rhododendrons. You'd be able to spy them out immediately, say, oh, there's another one trying to stay warm. And it's this visual morphology adaptation to winter conditions. They are native to the Himalayas for the most part. This is not because we're growing them at 57 degrees north in Scotland. This is a natural adaptation.
That's great.
Gardening continues throughout the botanics year-round, and regardless of what the weather has been over the past month, the horticultural team here, alongside our dedicated volunteers, have continued to be out and about, getting on with the tasks that have been possible with this inclement weather. Weeding is beginning. Indeed, the large bed directly off to my right is our herbaceous border, double-sided, 87 metres in length, 5 metres in width. It's an enormous bed, but quite stunning in its own right, and will provide seasonal variation year-round, but henceforth over the next 8 to 9 months. So we are weeding in here already, perennial, some perennial, annual, even ephemeral weeds beginning to come up through our mulch. Other work in the garden over the past 4 weeks have included ongoing hard landscaping work, improvement of paths, improvement of beds and edging. You might remember that we had some storm damage 5, 6, 7 weeks ago and involved some cleanup. Well, indeed, we have had further storm damage as well to deal with. All part of the management of the garden, but focused through our weather conditions. Well, we have a guest today who is Dr. Tyler Stevenson, and he quite rightly is indoors at the moment, not standing out in a 1 degree temperature. He's in the Cruickshank building, and it is the Cruickshank building where plant and soil science research occurs. It is also where we have the herbarium, and the herbarium is where Tyler is looking at specimens directly relating to his research. Your area of research is specialising in how environmental cues, environmental rhythms in a seasonal manner affect biota in general with their own growth patterns, reproductive patterns, and ultimately their senescence. You've chosen to look today at some herbarium specimens of a unique and specific plant species.
Yeah, so today we're going to look at the Arabidopsis, mostly because it's one of the best characterized and well-studied plant species. We know a large amount of how it responds to daylight, the length of the day, but also temperature.
Now, you say you're looking at Arabidopsis, and we are, but let's be very specific. There's a number of species of Arabidopsis out there. This is Arabidopsis thaliana. It is the first species of flowering plant to have had its genome formally read, if I can use that term, in the year 2000. And it is a plant that is of Northern Europe that can germinate, grow, flower, set seed and die all within a month. So it's an incredibly fast cycle, which is why it's such a useful plant for plant geneticists, indeed for your own research.
Exactly, and it's that sequencing of the genome that has been extremely helpful for understanding how the plant responds to temperature and light at a genetic level. So the main spots in the Arabidopsis that are responding are down here in these leaves, where there's 2 different pathways that are integrating environmental information. You have a light pathway or photoperiod pathway in which genes within the cells are responding to the length of the day. So you have circadian clock genes that are detecting primarily light in the evening time. So a long summer day are activating these genes, leading to a cascade of events that activate a gene known as the flowering transcript.
And this is in the meristematic tissue area here, the area of mast cell division where you can get both root growth going down, stem growth going up.
Exactly, but it's that flowering transcript that activates another gene known as leafy, giving rise to the growth of the meristeme.
A gene called leafy.
A gene called leafy.
That's fantastic. I do like that. Okay, so forgive me, to reiterate at this point, light levels...
Light length.
Light length.
Like length.
And does that then correspond to temperature a little bit as well?
You have a different pathway for temperature.
Right, okay, we'll get to that. So with light length, there's a gene sequence here that is triggered to produce stem growth, and from that, leaf growth.
Exactly. So now the temperature pathway
Yep.
activates a different cascade of genes known as vernalization. Okay. So in prolonged coldness, you have a buildup of this transcript that leads to the activation of that same flowering transcript gene that activates leafy. So
they operate, no doubt, in parallel, but independently.
Exactly.
So I'm pausing because I'm thinking this through. Generally speaking, day length corresponds to, in both hemispheres, the sun having a higher arc, therefore there is going to be slightly improved temperature, but temperature generally improves more slowly than light levels, and therefore the plant would genetically have its growth triggered initially with day length, temperature is subsequent. Is that a fair comment?
Absolutely. So photoperiod is the primary cue that not just plants but all organisms are using, because it's a reliable daily cue, where temperature varies a lot to a greater extent. So for these types of plant species, it's best to use the annual change in day length as the ultimate cue to time flowering, and have temperature as a supplementary cue that supports when you would want to have a flowering plant.
Now I'm fascinated with your last comment there of a flowering plant, not a growing plant, because earlier this month we had deep snow on the ground outside. You'll remember it well yourself. And at that time I was able to have a brief conversation with Dr. Leslie Lancaster looking at rhododendrons and how their leaf morphology was changing with the cold air temperature and the snow on the ground. Some of those rhododendrons we were looking at are now not growing per se, but beginning to flower. And that's because of day length as opposed to air temperature, based on what you're telling me.
Absolutely. But the thing to remember is that all the genes are going to be relatively similar, and it's just going to be a variation, and it's the control of that signaling cascade that will be the difference between when species are going to flower.
Very interesting. I'd love to ask you much, much more. I fear if I did so, A, I'd be beginning to move out of my own area of knowledge set, B, I know we'd run out of time. Can I thank you very much for using the herbarium, highlighting a few of these specimens. We should just add that as per the herbarium labels here, so we're looking at specimens of 1866 on this occasion.
So this is quite special.
Indeed. It's super to see specimens of 150 odd years. Preserved to a very high standard, and using, of course we should add, using modern scientific techniques, this material can now, tiny little pieces can be removed and be genetically screened.
Exactly.
Which is very exciting. As ever, Tyler, thank you so very much.
Thank you very much.
As ever, we are highlighting not just a interesting, indeed fascinating resource and area that is affiliated with the Botanic Garden here at the University of Aberdeen, but being able to highlight the skill, the knowledge, the dedication and research of some of our leading practitioners here at the University of Aberdeen. Next month, there will be more to show and more to tell. We look forward to having you joining us then. Thank you.